So, ladies and gentlemen, very welcome to the SMC BMC Design Award 2022 here at JEC World in Paris. Today we will announce the winners of this competition organized by the European Alliance of SMC BMC and with the theme Sustainable Living. You will see in a minute the 3 finalists which will present to you the winning projects, and they will present them in a very short time period, 6 minutes, and we will be very, very sharp on time. And then later this afternoon at 3:15, Joan MONTOBBIO, who's sitting right there, chairman of the jury, will invite the winners to the stage and hand out the awards. Joan, please.
Thank you, Thomas, for the introduction. I need to remove my glasses. It's going to be difficult. First of all, dear all, great to have all of you here coming from this award ceremony. In special, I want to welcome our students, our finalist students, coming from Belgium, Germany, and the Netherlands, to be with us today and to defend your projects. You know, SMC and BMC are well-established material solutions for many years. We are using in quite demanding applications because of the strength, durability, or lightweight. But we, as a European Alliance for SMC and BMC, we have the responsibility to not just focus on what is existing today, but to try to develop new markets and new applications. So that's why we are pleased to present the 3rd edition of our design competition. Speaking on behalf of the jury, I must say that we are really impressed with the great ideas and the great solutions that the students have generated. The jury has been evaluating all the projects in 4 areas or aspects: creativity, end-user functionality, sustainability, and also feasibility in SMC and BMC. Of course, if there is an award, should be a prize. So basically today, for the winner, there is a money prize of 7,500 euros for the winner, for the gold winner. And besides that, we are also going to invite the winner to work with different members of our organization to further improve product design and investigate in potential commercialization of your solution. So now it's your time. So let's see what you have to say and what you have to show to us.
Thank you very much.
Hello?
Do you hear me? No. I'll try this microphone. Thank you very much, Joan. I invite Antje Verhellen and Boukje Adriaansen from Thomas More in Mechelen, Belgium, to come to the stage.
Dear attendees and members of the jury, my name is Boukje and next to me is Antje, and today we'd like to present you our project called SeaWeeds. SeaWeeds offers a solution for the ever-growing worldwide scarcity of fresh water and available space on our planet. Powered by solar heat, we will purify salt water into fresh water. This way we can cultivate plants on otherwise unused space. The garden is fully self-sufficient or self-supporting. This way our plants have the correct amount of water. Now, why is this so relevant today and in the future? First of all, there's a big scarcity of agricultural land for food production, while vast areas of water are available on our planet. However, all this water, only 3% of it is fresh water. All the remaining is salt water we can't use today for food production. Agricultural activities are also huge energy consumers, and every step to reduce our carbon footprint is one in the right direction. We believe seaweed could take the first step. Farms on floating gardens also don't suffer a lot from insects and animals as gardens on land. This way, we can eliminate use of harmful pesticides. Our garden consists of modular elements. They can be used individually or can be used together in larger entities. The whole body is made of SMC. These parts will be glued together. All the remaining parts can be easily disassembled. This will make recycling much easier later on. The whole base, as I just told you, is made out of SMC. The longitudinal reinforcement plates make sure, I'm sorry. The void spaces in the double bottom make sure our system will stay afloat. Longitudinal reinforcement plates provide for the necessary structural strength. The well-thought design creates compartments which will keep our system afloat even in case of a leak. Now, how is this all made? First of all, our distillation cells are placed underneath a walkway and underneath the water level. This way, we don't need a suction pump. We cover these distillation cells with hatches with a cover. This way, we can easily access the distillation cells for maintenance or harvesting or salt. This salt can later be consumed or sold. The planters will be filled up with leca balls or expanded clay balls. They will take care of the water management. The rest we will fill up with the necessary soil for our plants.
To make all the planters easily and safely accessible in all configurations, we provide a portable step. The element for the walkway is rough finished to create a skid-proof surface. The distillation cell, developed by researchers at the Politecnico di Torino, converts salt water into fresh water only using solar heat. One distillation can produce up to 500 liters of water per week in ideal weather conditions, which is enough for 50 tomato plants. One seaweed's element has room for up to 4 distillation cells, which can be added depending on the specific needs of the planted crops. The water produced in the distillation cells flows through the planters through perforations in the mutual compartment wall, where the leca balls absorb it and gradually release it to the plants. An overflow ensures that all the excess of water is drained to prevent the crops from drowning and to make sure that the system does not get too heavy to float. In contrast to farms on land, the modular seaweed garden does not disturb the local fauna and flora. In addition to growing crops, a byproduct is created from filtering the salt water. The residual product, the salt, is collected in the distillation cells and can be harvested and used for consumption. Of course, seaweeds can also be used in other environments with calm water, not only salt environments. For example, lakes or rivers with fresh water, with the only difference being that there will be no salt produced. Sheet-molded composite is the perfect building material for these floating platforms. As a lightweight, watertight, and corrosion-resistant material, it's perfect for this application. Thanks to the thermal resistance, the low expansion coefficient, and the strength properties, the body is not prone to deformations and provides sufficient sturdiness for the forces exerted on it. Seaweeds is very versatile and can be used in a lot of different contexts, supporting a sustainable society. We will illustrate this with 3 examples. Marit is a Dutch farmer. She lives in the Netherlands, and due to climate change, more land will flood in the years to come. Therefore, she combines her traditional oyster farm with a floating garden in the shallow mudflats in the Netherlands. In this way, she has more income, and she can actually sell crops and salt from her farm. Abdou is a farmer in Cape Town, South Africa, where fresh water is rare and droughts are very common. By using salt water to grow his crops, he can save up his much-needed drinking water and actually feed his family. The remaining crops and salt can be sold. Vineet is a chef in Dubai. He shares a floating garden with other restaurants in the neighborhood where he can grow sustainable herbs and vegetables for the restaurants in a city where salt water is abundantly available. In addition, the gardens also attract tourists, which is a great publicity benefit for the restaurants. Finally, we would like to conclude with a quote from Bjerke Ingels, which we strongly agree with. Sustainability cannot be like some sort of moral sacrifice, or a political dilemma, or a philanthropical cause. It has to be a design challenge. Thank you very much.
Thank you very much, Antje and Boukje. Very interesting. Thank you. Would like to call Isa Buitenhuis to the stage to give her presentation. And again, also for you, Isa, 6 minutes sharp.
Hi, my name is Isa, and I am going to show you how SMC BMC can improve the quality of life while at the same time reduce environmental impact. We are currently facing a rapidly aging population in Europe, and most of them live at home or with their family. And this creates a target group that is in need of products to support the quality of life. At the same time, we are all living in a world where water scarcity is a problem that must be dealt with. And did you know that one shower consumes 70 liters of water? An efficient solution to showering could bring huge benefits. That's why I chose my focus group, bathroom industry for middle-aged and elderly. As you can see, there are some changes in the bathroom of elderly. And one of the first changes is a shower chair. This provides stability and prevents falling in the shower. Here are some more examples of the current design of a shower chair. And my user research shows that the current design is unattractive and definitely not stylish. To sketch my target group, I created a user persona. Meet Paul. He is 71 years old, and his motivations and frustrations are shown. One of his frustrations is feeling like a patient while showering on a chair. With my vision, I want to respond to people like Paul. I want to enhance the day-to-day routine of middle-aged and elderly by creating a luxury and attracting experience for seated showering. In addition, I want to reduce the water consumption by creating awareness on the shower behavior. With the light turn, my vision can be realized. The light turn is a combination of a chair, a shower head, interface, and light system all into one product. The light turn consists of different parts, and it will be used during different stages in the user lifetime. On the left, you see a woman who is 41 years old. She bought the light turn because of the simple and aesthetic design, and she likes to lift up her leg while shaving her leg, and the lower supporting part allows her to do that. 30 years later, she's ready for a shower chair. The lower supporting part will be replaced by a chair. The product lifetime of the shower increases, and the durability of the material SMC is optimally used. So the consumer can choose the combination A and B or A and C, and all the three parts are made out of SMC, sheet molding compound. This material is very durable. That's why the shower grows along with the user. It is also strong and stiff enough to endure the forces of the user, and it has a smooth surface so it's easy to clean. Let's discuss some more details. We're using a LED and water-saving shower head at the same time, and the three cushions are providing enough friction for the safety of the user. There's an opening in the wall for the water outlet, and the sides of the light turn are connected to the wall, and there's some space in the middle for the water system. Also, a hand shower is connected to the chair. This is preferred during seated showering because the user has less freedom of movement. Using a hand shower, the user is able to reach all the spots on the body. And finally, an interface will show some infographics about the water use. But how is this product placed in a user context? First, the user puts on the shower. When the water is heated up, the light will turn green. The user sits down, grabs the hand shower, and starts showering. After 5 minutes, the light will turn yellow. The user is reminded to quit showering, and he stops the shower. And finally, he will gain some information about his water use. Hot water has 50 times more environmental impact than cold water. So taking longer shower is an easy way to reduce your environmental impact. Showering 5 minutes instead of 9 minutes, which is the average right now, could make a huge difference, as you can see in the graphs. But how is this product be implemented on the market? I suggest a collaboration between SMC BMC and a bathroom company like GLOWACZ. SMC BMC will take advantage of the name and marketing of GLOWACZ, and people will get familiar with composites in the bathroom. GLOWACZ will expand their product portfolio with a durable material, and the sales of their water systems will increase. SMC BMC will create the 3 parts in SMC, and GLOWACZ will provide the shower system. And when the user wants to switch the parts, the component will be returned to GLOWACZ and it can be used somewhere else, resulting in a circular system. This way, I respond to the long lifetime of the material SMC. Because of the heavy loads the parts will experience, the assembly on the wall is very important, and I sketched the first idea for a mounting plate that can also be made out of SMC. I also asked the target group what they are willing to pay for this product, and it's about this following range. My calculations indicate that this is feasible. The lantern is, of course, a concept design, and I did an initial approach for the basic engineering. Detailed engineering must be further investigated. This is the lantern, a sustainable and comfortable showering solution. Thank you.
Thank you very much, Isa. Also very nice presentation. Cornel, please come to the stage. Also for you, 6 minutes, sharp.
All right, thank you, Thomas. I'm here to present my concept tile turn. My name is Cornel. And I'm going to start with a number, 5.2%. That is the amount of time you would be comfortable in your house if we would have no climate appliances at all. But in reality, we do have appliances. A lot of them. We're in a constant fight with the climate to be more comfortable. And that's not weird because 75% of the time we spend indoors, and being comfortable is important for your mental and your physical health. And nowadays the pandemics have taught us that remote work is possible, and it's something that's here to stay, as study shows. So that even fuels more the need for that comfortable climate at home. And I want to specify on like one specific place in the house, which is an attic space under a gable roof, because that's a space that used to be just used as a climate buffer, an extra space that protects the inside from the outside. But nowadays it's more and more transformed into a living space. And I interviewed people that live in that place, in places like that, and they all see the same phenomenon. Too hot in the summer and too cold in the winter. I've got 2 striking quotes that really sum up the problem. On the one hand, someone that told me that they sleep in the kitchen in summer to escape the heat, and someone else told me that they bought extra electrical appliances to be more comfortable. So we've got the discomfort and a lot of energy used to fight that discomfort. And sadly, that energy use is still mostly from fossil fuels. And even though we all should work towards a greener future, I think it's also important to consider using less energy. And that is where climate adaptive design comes in. Working with the climate instead of against it. Here you see 3 people. They all changed their attic space in a different way, but they all want a more comfortable climate. And within architecture, that can be reached if we don't see it as something static, but something as more dynamical. Looking at the outer layer of the building, the skin of the building, and changing that. Because unlike skins of animals and humans, buildings don't usually have automatic thermal regulation yet. I present to you tile turn, a roofing that will do all the normal functionalities of a roof, but on top of that, it will also vary in solar reflectance by changing the color of the roof, and it will vary in heat dissipation by slightly shifting the panels. This will cope with the extreme volatility of the temperature in attic spaces. What is it made of? Sheet molding compound, of course, and then one panel is added by a black one on the other side. And sheet molding compound is perfect because it's durable. You want to use your panels for 30 to 50 years. It's also weather resistance because decolorization or the change in smoothness of your material will strongly affect your desired solar reflectance in a negative way. So you want your material to be weather resistance. I think fire resistance speaks for itself in a housing context, and low maintenance is good because you don't want to get on top of your roof every month. Well, these panels are slide on rails, and those rails are connected in a mechanical system that uses the rotating principle of trivision billboards from the advertisement industry. Those are relatively simple mechanism, but it's extremely good against weather conditions because it's always outside, as the roof would be. And that system will also not fail very often because within the advertisement industry, failure to advertise as promised comes at huge cost. So it's a very steady system. Then the solar reflectance principle is quite a basic one. I think everyone knows in summer you wear a white shirt. Why? Because you're cooler. Same goes for the building. White roof will reflect the heat and the black one will absorb it, making your environment more hot. That comes with some benefits. First of all, financial benefits. Your energy bill will be lower and therefore you'll save some money. But because it's just the roof of the house, that's not substantial enough. So luckily, there's also the increase in comfort because the panels will cap off the temperature extremes that most people experience. And then there's the more sustainable lifestyle that is not in the least stimulated by getting more insights in your energy consumption and in how you can regulate it. And getting insights and using less energy makes you also more independent from the energy market, which is very prone to volatility due to, for example, geopolitical changes, as we can see nowadays. The more societal benefits is mostly focused on the white roofing, because white roofing will help cope with the heat island effect, which goes with these four examples, with these four benefits, that the city also is more climate friendly and reduces the strain on the network. Lastly, I can imagine some of you might think some places have an eternal summer. We sadly don't have that, but that's very true. Some places do. And that's why the concept will only work in a more continental environments, as you can see here. Then the pricing, also something we should talk about, is between 100 and 130 euros, something that fits like this in the existing material market. It is at the more expensive side, but still within the price that people are willing to pay for roofing. And as you can see, thatched roofing is the most expensive one, and people are willing to pay for that because it is a more sustainable material. Lastly, I would like to round up that I hope that climate adaptive design will be more integrated into people's lives and that people turn over their roof before they turn on the radiator. Thank you very much.
Thank you very much, Cornel, as well. Well, all three were great presentations. You can see SMC BMC materials are well-established materials already around for decades. But it's very encouraging to see that there are many new applications possible, many new ideas possible. Later today, we will have the official announcement of the winner of the award. At 3:15, we'll have the ceremony, and we hand over the awards. So I would really like to invite you to come back by then and celebrate with the winners. Yep, thank you.